Hey everybody, checking in on chapter 6. We are so far into the course. It's kind of crazy how quickly the summer's going, but I just wanted to highlight the high points from chapter 6 about significance testing and type 1 and type 2 errors and p-values and stuff like that. So these are terms you'll actually hear kicked around kind of a lot in literature and in just conversations about setting hypotheses and testing these hypotheses and things like that. So what I wanted to start with is actually the idea of a hypothesis. A hypothesis is a prediction. After you have your research question, you set for yourself and for your research a hypothesis, which is a prediction about what you think is going to happen. So it sounds very obvious, but I've actually spoken to a number of people about various projects they're working on, and I've said, well, what's your hypothesis? Like, what's your prior on what you think is going to happen, and they haven't been able to answer that. So I think there might be some kind of misconception that if you have a prediction, it means you're somehow confounding the research that you're doing, and that's not actually true. You need to be able to articulate what your research question is, and then what your hypothesis is. So that's just like a pro tip there. If somebody ever said to you, like, well, what do you think is going to happen? You say, oh, I don't know. That's not particularly impressive. So keep that in mind. Just kind of like a nomenclature semantics type of thing. When you talk about the null hypothesis and the alternative hypothesis, that's HO and HA is in the textbook. The textbook says this a number of times in the chapter, but you're never accepting the alternative, you're rejecting the null. So your assumption, this as you set it up, is that the null is true, and then you are showing the null is or is not true by using the alternative. So you never accept the alternative hypothesis, you accept or reject the null, or you say the null cannot be rejected. That's typically how that goes. So there's a lot of language around that in the book, but that's for real. That's not just like the authors of the text being picky. You don't actually ever accept an alternative, you reject the null. Okay, so in order to do that, you rely on significance tests and hypothesis testing, and typically for that you would use a p-value. And there's actually a lot of debate. If I can find it, I'll link to it on the D2L site, but there's some debate in the research community writ large, the social science research community, about whether the p-value is still like the best value to use. And the question is then kind of like, what if not that? In terms of testing significance and seeing if the null and the alternative hypotheses are distinct. So if I can find that, I will link to it, but I think if you just Google like New York Times p-value, it might pop up. It's like a good nerdy read if you're bored or if you're interested. So the short story about the p-value, and if you think about the normal distribution, I never should have gotten rid of that poster that was behind me, but if you think about that, that might be helpful here. So the p-value is the probability that the null hypothesis is true. Right? So for example, if your null hypothesis, an example that they give in the book is about hiring managers and discrimination based on gender. So if your null hypothesis is that there is no difference in the rate of hiring of male versus female managers, and your alternative is that there is a difference, using a p-value will get you to that answer, which one of those is actually correct. And the lower the p-value, the more likely it is that you will reject the null hypothesis. So let me say it again more like succinctly. The lower the p-value, and typically those thresholds, those alpha values are 0.05 or 0.01, the lower those are, the more likely you are to reject the null and say that there actually is a difference in the rates of hiring between male and female managers, as was that case. So there are a lot of good examples in the book. If you think about the tails of the normal distribution, that's kind of where that 0.01 or that 0.05 live. Relative to the values closer to the middle. So the lower the p-value, the more likely you are to reject the null. Depending how you set up your null and your alternative, that's typically what you want. The null hypothesis is most often like the baseline or like an assumption, or stating that a value is 0 or that two values are not different. So very rarely is it the case that you want to show that two things are the same, or you want to show that a value is 0, you're typically trying to test for whether it's something else. So that's not always true, but typically it's like a win if you can reject the null, though not always. Okay, I think that's all I'm going to say about that. Again, this is meant to be super high level. If you have questions call me, email me, whatever. The book gets to a little bit about two-sided versus one-sided hypothesis testing, and that just really depends on what your question is. Your research question is. So there are some good examples in the text about political views, liberalism, and conservatism, as well as young women with anorexia and doing weight studies on these women with anorexia. And that kind of gives some examples about two-sided versus one-sided. So, and I'll just give a couple examples too. So if you are doing a two-sided hypothesis test, you are testing whether two things are equal or not. So this thing about the proportion of male versus female managers. Your null is that the proportion is equal. Your alternative is that the proportion is not equal. So it could be higher or lower. Typically, when we talk about gender discrimination, you're assuming that the proportion of women hired is lower. But technically, that way that question is posed, it's a two-sided hypothesis test because you're seeing whether or not they are unequal. A one-sided test would be if you were explicitly testing whether something is greater than or less than your null. So for example, your null could be women make on average $60,000 a year, just on average across the country. And your alternative could be women make less than $60,000 a year in general. So that's just one-sided because you're testing for less than rather than just not equal to. That's kind of a silly example, but hopefully that makes the point. If it doesn't, call me and we'll talk about it. The book gets into a little bit about testing for proportions, and that is really, it's the same logic. It relies on a z-score rather than a p-value in some cases. I think we talked about z-scores in another chapter about the distance from the mean and number of standard deviations from the mean, but it's the same rationale, and I know the example given there is something about the proportion of voters who are in favor of a different tax or something, but the logic is completely the same. And then just to reiterate again, it's not just like a weird semantic thing about rejecting versus accepting, but you always reject the null rather than accept the hypothesis. And I have that in my notes like 3 times, so I'm going to say it at least 3 times. One or two more things to talk about here. The types of errors you can make when you are doing these significance tests, the type 1 error and the type 2 error. And the book, I think, does a pretty good job of laying this out. The examples most often used when you talk about type 1 versus type 2 errors are someone who is on trial and then someone who is doing like a medical trial. So to use the example of like a criminal who's on trial, a type 1 error means that you reject the null hypothesis when you shouldn't. So in the case of somebody who's on trial, if your null is that that person is innocent, because you're innocent until proven guilty, right? That's a whole other conversation for another class. Innocent until proven guilty in this country. So your null is that they're innocent. Your alternative is that you are guilty. So if it's a type 1 error, that means you reject the null hypothesis when you should have. You're going to send an innocent person to jail. Okay? Type 2 is the opposite. You don't reject the null when you should, right? And so in that case, someone who is guilty of a crime gets to walk, right? And so you can kind of see how that logic would be applied to people seeking medical treatment, people who are treated when they shouldn't be, not treated when they need to be, etc. So type 1 is you reject when you shouldn't. Type 2 is that you don't reject when you should. And each of those, the book outlines this pretty well. Each of those have their own like unique set of issues. One is not like worse than the other necessarily, but it's not great, right? Like either way, it's not great. Either you like imprison someone who's innocent or you let a guilty person walk. So that's why you have to be careful with everything that the book discusses about the samples and about the strategies and about the randomization and all of that. But that's just kind of like a practical, like a real life example. The last thing I want to mention, and this I think relates to a lot of what I feel like I've harped on over the past few weeks, is what the book sets out, and I think they do a good job, about statistical significance versus practical significance. And this goes back to all of these conversations we've had about audience, about context, about things like that. Like, just because you have a significant finding does not necessarily mean like you're going to blow people's minds with your research and your like actual finding. Like having a statistically significant finding, or like you're able to reject the null because, you know, your p-value is 0.04 or whatever it is, doesn't actually mean what you're studying is important. And that's kind of a rude thing to say, and I'm not trying to be rude, but if you look at what the text kind of talks about, like you really need to think about whether what you're finding is like something that's actually relevant and actionable versus like a distinction without a difference, and you think you're like some kind of big deal because your hypothesis test was significant and yielded one thing or another. So that's not really different than anything else I've said throughout this whole summer term, that you really need to be paying attention to like what's actually happening and who you're actually talking to versus running around saying, well, the p-value is 0.04, so obviously it's going to like be a life-changing result, and that's not actually true. I went to grad school with a lot of people who did that, so personal experience. I think I'm going to stop there. The book then goes into talking in some detail about binomial distributions and things like that. We do not need to get into that for the purposes of this course. So I hope this very high level, this was only about 10 minutes, 10-minute overview, was useful. Always call me, always email me if you have questions, and I will be back with the Chapter 7 video pretty soon. I hope everybody's having a great day. Bye!